I'm asking to my local AI coding assistant in a full natural language to analyze a file in my current project. Instead of freezing or throwing an error, asking what file you are talking about, it instantly gets which file, indexes it, runs a semantic vector search, and gives me an answer based on the file in milliseconds. No cloud tokens, zero subscription costs, completely local and private. In my last video, I built a local AI coding assistant using Python and Ollama. Today, we are taking it one step further and adding context-aware file parsing using Qdrant vector database and a chunking strategy that keeps local interface blazing fast. Here's exactly how I built it. If you are building a proprietary client software, you may not just feed raw company codebase into external cloud tools. It's a massive security risk. But building a local assistant has a massive bottleneck: the context window. If you blindly ingest full directory structures or paste massive source code files directly into a local model as a prompt, two things happen. First, your generation speed tanks because processing long prompts locally destroys token throughput. Second, small models like Qwen 2.5 coder start losing accuracy and hallucinate when bloated with irrelevant code lines. To build a true context-aware local AI coding assistant, we couldn't just pass text. We needed local semantic memory. Let's look at the underlying architecture. We keep our core setup lightweight and split the system into a three-stage pipeline. The ingestion engine. When you mention a file path in the prompt, getFilePath from user input function understands it and passes it as chunks to LangChain's RecursiveCharacterTextSplitter. The local vector store. These chunks get converted in a list of documents and then they are immediately embedded and inserted into an instance of Qdrant running locally. Qdrant handles our semantic storage. The brain. Lastly, our Python orchestrator pulls the most relevant snippets from the Qdrant storage based on the query, then adds them into the prompt, finally sends a streamlined payload directly to the Ollama model running in the background. This is a local RAG pipeline tailored specifically for source code. Let's dive into the two engineering decisions that made this work cleanly without making the app feel bloated. Decision 1. Smart code chunking over brute force splitters. If you split source code by absolute character length, you break functions in half, separate variables from their context, and completely ruin the semantic meaning for your vector embeddings. To fix this, I utilized RecursiveCharacterTextSplitter. Instead of splitting blindly at character 500, it looks for language-specific boundaries like double new lines, individual new lines, and space indentations. This means logical loops, function bodies, and classes stay grouped together in the vector space. It guarantees that when Qdrant returns a code snippet, it returns a complete mathematical block that the LLM can actually read. Decision 2. Lightweight Qdrant setup. For a developer tool, nobody wants to manage a heavy database container setup just to chat with a file. I configured Qdrant to run entirely locally, utilizing fast vector metrics to keep execution times virtually instant. When a user queries a file, the Python orchestrator computes the question's embeddings, searches the local vector index, and pulls only the top matching nodes. We save precious context space by ignoring the boilerplate and only passing the real logic blocks the user is asking about. The entire repository, fully developed with the RAG pipeline, the Qdrant connection logic, and the core Python orchestrator, is completely open source and free on my GitHub. You can pull it down, connect it to your local Ollama instance, and have a fully private coding assistant running in under 2 minutes. The link is in the description below. If you want to see how real software gets built completely from scratch with good architecture, hit that subscribe button, leave a comment with what we should implement next, and I'll see you in the next build.